All right, this is Grade 3, Module 2, Lesson 11, and we're going to be solving word problems and using all four operations. I'm going to largely use those classic tape diagram kind of things, and the reason I'm going to use the tape diagrams is because this lesson is really cool because the word problems involve all four operations. So students aren't going to immediately know whether they're supposed to add or subtract or multiply or divide because they're mixed. All four of them are going to be included. And so the idea is using these really cool tape diagrams, when students are able to draw the tape diagrams, suddenly it becomes amazingly clear based on whatever the tape diagram looks like, whether they're supposed to add, subtract, multiply, and divide. So let's do some examples, one of each, and you'll see what I mean. All right, so in this example, it says Karina goes on a hike. She brings a notebook, a pencil, and a camera. So we've got these three things. The weight of each item is shown in the chart. What is the total weight of all three items? There's a couple ways we could do this, and one way to do it is to just do a single bar, and it might look like this. So we've got three items, and we don't have to worry about necessarily the three items looking the same length. And we've got the notebook, which is 312 grams, and I'm just going to label 312. And we've got a pencil, which is 10, and we've got a camera, which is 365. And then the question is, what is the total weight? Right here, what is the total weight? In which case you look like this, all right? And we'll put a question mark there. So this tape diagram, this resulting tape diagram, is a classic tape diagram that suggests addition. You have unequal segments, because we got 312, we've got 10, and 365. So they're unequal lengths. If they were equal lengths, we might be talking about multiplication or division, but because they're unequal, it means we're probably talking about addition or subtraction. But then because it says we want to know this whole length, that immediately kind of puts it into the realm of addition. So we're going to add 312 plus 365 plus 10, and we're going to add. And with third graders, man, there's a ton of different ways they could add. I'll just add the standard way right now. 2 plus 5 plus 0 is 7. 1 plus 6 plus 1 is 8. And 3 plus 3 is 6. And so we've got 687 grams is the total. Another way they could have drawn their bars is you have three items, and I'm going to put item 1, item 2, and item 3, and I don't remember, notebook, pencil, something or other. And then we would draw their bars like this, and we might make them longer or smaller depending on the numbers. And then let's just do it. Let's see what the numbers were. 300. So this number was 312. This number was 10, and then this number here was 365. And another way of indicating or drawing the tape diagram would have looked like this. So there's no one magic way to draw the proper tape diagram, but in general, students are going to start to recognize that this, when the tape diagram looks like this or like this, it means we're going to probably be adding. All right, let's move on to this example. Together, a horse and its rider weigh 729 kilograms, so we've got a horse and its rider. The horse weighs 625 kilograms. How much does the rider weigh? A couple of ways we could draw the tape diagram. One, you've got a total of 729 kilograms, and we know the horse weighs 625, and 625. That's what we want, 625. And then it says how much does the rider weigh, so our question mark is right here. So we have horse, rider. All right. And then students are going to begin to recognize that, oh, this is kind of like a part whole. This is, whoa, there. This is the part, and the entire thing is the whole. And when you know the whole, and you know one of the parts, that means you're going to use subtraction to find the remaining part. So we've got 729 minus 625, and we subtract, and oops, I didn't need to borrow. I didn't need to borrow at all. So that's actually 2 minus 2, which is 0, and then this really should be a 7, so 7 minus 6 is 1. So the answer is 104. So 104 kilograms would be the proper answer. And now, that's one way we could have drawn that tape diagram. Another way we could have drawn it is more of the way they do it in Singapore. You label, you have a horse, and you have a rider. There's our two subjects. And you begin by drawing each of them, the bars the exact same length, and then you label. And it says the horse weighs 625 kilograms, so we're going to label this 625. And then it says together these two bars weigh 729. And then how much does the rider weigh? Well, upon inspection we can see that, well, the rider really should be much, much smaller. So let's revise the bars a little bit to make them more realistic. And there's our two bars. And the big question is, what is the rider? And so this is another way to draw the tape diagram. And this is probably what it would look like in Singapore. But either way represents subtraction. So in this one, Teresa's soccer team fills up 6 water coolers before the game. Each water cooler holds 9 liters of water. How many liters of water did they fill? So in this case, we would probably draw, to represent those 6 water coolers, we're going to draw a tape diagram. And we're going to cut it up into 6 equal-sized sections because they're identical water coolers, and each water cooler holds 9 liters. 9. And we don't have to label all of them, but I'm going to because I have to draw 6 of them. And then the question is, what is the total? So right here. So this is one of those classic tape diagrams that suggests either multiplication or division because all of the pieces are equal-sized. And the moment you're talking about equal-sized pieces, that suggests you're either talking about multiplication or division. Not always, but generally. So in this case, we know that we're going to do 9 times 6, get 54, or we could have added 9 6 times. 9 plus 9 plus 9 plus 9 plus 9 plus 9. And if your students don't know their 9 times tables yet, perhaps they could have done 10 plus 10 plus 10 plus 10 plus 10 plus 10, which is 60, and then subtract out 6 because we were really supposed to be subtracting or adding 9s, not 10s. So 54 is the correct answer, so 54 liters. And that's generally the classic way to draw the tape diagram. Generally, there's not a second way to do it, but if your students come up with a second, equally mathematically appropriate way to draw it, that's fine too. And our last example, Dwight purchased 48 kilograms of fertilizer for his garden. He needs 6 kilograms of fertilizer for each bed of vegetables. And then how many beds of vegetables can he fertilize? So we're going to draw a representation of those 48 kilograms. And there's our 48 kilograms of fertilizer. And we know that he needs 6 kilograms for each bed. So here's 6 kilograms, here's 6 kilograms, here's 6 kilograms. And the idea is we're going to keep going until we reach 48. And so the question is, how many beds? So in other words, how many groups of 6 are we going to need? And so there are a lot of ways we could have done that. We could do this. We could either say 6 times what equals 48 if your third graders are there. We could have used division. 48 divided by 6 equals what? Or we could have just used repeated subtraction and just keep going and going and going, or addition, really. We could go, okay, 6 plus 6. Let's do repeated addition. 6 plus 6 is 12, plus another 6 is 18, plus another 6 is 24. I'm going to keep going up over here. So with that 24, plus another 6 is 30, plus another 6 is 36, another 6 is 42, and finally the last 6 is 48, and then we would count. We'd say, well, there's 1, 2, 3, 4, 5, 6, 7, 8. So the answer is 8 beds. But the important thing is, this is the classic look of what a tape diagram would look like that represents division. So you've seen an example of addition, subtraction, multiplication, and division, and how the tape diagrams look different from each other depending on the operation that it is suggesting. And that is Grade 3, Module 2, Lesson 11.